Hello and welcome to today's webinar. My name is David Cash. I'm a member of the marketing team here at Mountz, and I'm glad that you've taken the time to join us today. If you have any questions regarding our topic, feel free to put those into the chat and we'll take a look at those at the end of the presentation. But our topic for today is how to calibrate a torque wrench or a torque screwdriver. Now, the process of doing a torque calibration is not very difficult to understand or difficult to do, but there are some things that require a little bit of knowledge to know what's going on and how different things may affect the actual calibration process. Now, the reason that we do torque calibration is to make sure that our tools are being repeatable, that they're repeating accurately, so we can have some sense of reliability that these tools are performing regarding the torque output that we are looking to achieve, to make sure that we're getting the correct clamp force that we're trying to achieve with that fastener. So this is obviously the reason why we would do the calibration process. Now, this is nothing new within the industry of torque-related products or any measurement type of product.
Hey, Dave.
Yeah.
I think you're muted.
Oh, shoot. You were right. I'm not sure how that happened, but...
Yeah, we had some technical difficulties. Sorry.
Oh, okay, no problem. All right, so we can start over. I'm sure everyone saw that I'm Dave Cash, but anyway, yeah. So I'm a member of the marketing team here at Mountz, and so our topic today that we're dealing with is how to calibrate a torque wrench and a torque screwdriver. And as I was explaining to just myself and myself only, the calibration process, the reason that we do this obviously is to make sure that our tools are accurate and that they are repeatable and that we're getting the correct amount of torque being achieved by this particular tool to get the correct clamp force that we need to stretch our fastener to the correct clamp load. So this is the reason that we do all of this. And so let me make sure that you can still hear me. Everything is good. Okay, fantastic. And so this is why we do that. Now, there are a number of different components that go into the actual torque calibration process. But when we do the actual process itself, we are checking or measuring the device that we're using, and we're comparing it to another device, and the accuracy between the two, the one that we are comparing with must have a higher standard of accuracy than what we are measuring. And in this case, if we're dealing with a torque tool, and then we are measuring that torque tool on a torque analyzer, that analyzer is going to have a much greater accuracy statement than the actual tool does itself. So we can make sure that we are well within the tolerance of the analyzer and the tool, in our case, as we're measuring the torque calibration. Now, that standard may be different for different things, but in our case, it's typically a 4-to-1 rate. So calibration and quality standards. There are a lot of different types of organizations that have different types of calibration processes, and we'll take a look at what some of those are. But everyone is probably very familiar with ISO, the International Organization for Standards. Now, they do have different classifications of different things that are related to ISO, and we'll touch on those here in just a second. Next is going to be N.I.S.T, or the National Institute of Standards and Technologies. We also have the ANSI, the American Standard Institute, and ASME, which is the American Society of Mechanical Engineers. And these organizations all have different things that they measure to certify a torque tool within their process. Now, ISO, if you're an ISO 9001 company, Then you are in the continuous improvement type of mode, and you need documentation to exercise that or to when you have an audit to make sure that you're providing documentation of that. Torque calibration can be part of that audit. The ISO 17025, or I'm not sure why there's an O, but a lot of people say O when it's just 0, but 17025 is a calibration standard for a laboratory, and also certain tools can be calibrated to that standard. There's also the ANSI Z540 standard, and then there are a couple other international standards dealing with the ones that we have here are a British and a German standard. As well. So depending on the type of tool that you're using, the classification of that tool may fall within different uses and different calibrations for a particular type of tool. Now, when we're talking about doing a calibration, we're actually doing a traceability type of train as it relates to how we can be sure that the output that we're getting is the correct torque output. And for the torque related product, it all starts with wheels, segment arms, and weights. And this is how we calibrate a torque analyzer and torque sensor. We use a dead weight system, which is using our length times our force. And this is the unit that we use, or the types of products that we use to calibrate a torque analyzer. So that system is traceable to the weights that it may, or to the scales that may be used to measure those wheels and weights. Those are what we use to calibrate the torque analyzer. And then the torque analyzer is what we use to calibrate the torque wrench and the torque screwdriver. So the tools are traceable to the analyzer, and then the analyzer is traceable to the actual wheels and weights that were used to calibrate that sensor. So that is one aspect of understanding how that calibration train works. And next is going to be the actual calibration intervals that are used. And there are several different types of calibration cycles. Now, typically, most torque tools, most torque hand tools, are going to be a classification of an ISO 6789 tool. And that classification states that those tools must remain in calibration for at least 5,000 cycles for those tools to be considered an ISO 6789 tool. And that could be either a torque screwdriver or a torque wrench in those classifications. Now, at Mountz, we do have a couple of different tools that have a much higher cycle that we guarantee. And that's going to be our FG torque screwdrivers. We will guarantee that for 20,000 cycles. And then we have our FGC cam over wrenches, which we guarantee to 10,000 cycles within that specification. But this is the ISO spec for hand tools if they want to be classified as an ISO 6789 tool. Now, what most people are familiar with when it comes to calibration intervals is going to be a time-based system, meaning that a tool has a calibration date that it is good for after that calibration has happened. And that could be every 6 month, it could be a 12 month, could be 18 month. It's basically dependent on what your internal process might be for that particular tool's use in its application. And there may be scenarios where that frequency is increased or decreased. So every 6 months, this tool gets taken out and gets sent out for calibration. That could be one calibration interval that is being used. Another type of calibration cycle or interval is done performance-based. And this can be a little bit of a situation where people may not necessarily grab onto this or use it that often. However, it is a process of where we are using the tool's performance to dictate when it gets calibrated. And that's done through a process called torque verification, where we use a torque analyzer, and that frequency of the tool being checked happens at a greater rate than the calibration cycle. So for example, if we have a tool that typically has a 12-month calibration cycle, if we move to a torque verification type of process, this tool would be tested maybe once every 2 weeks, once every month, just to make sure that it's still performing within its range or acceptable limit for that tool. If we see that that tool is starting to reach the outer limits of the acceptable criteria for that particular application, then that tool then gets removed and then sent for calibration. So this really helps to prevent any type of scenario where you're using a tool or the frequency use of that tool is very, very low, and money is being paid for a calibration when there is a very low use of that particular tool. But a performance-based tool isn't for everyone. But again, if you want to grab the information for that information during the verification process, that information can be used again with your ISO 9001 process, if you would like. And then you are also making sure that your tool is staying within its acceptable limits during the period that it is being used in between cycles. So that is the performance-based type of calibration cycle. Now it's going to lead us to our poll question for today. And that question is, do you currently use a torque verification process to check your tools currently? So let's go ahead and we'll let that play out here, and we'll take a break and grab a drink of water. All right. Thanks very much for participating in our poll. We're right at about 60% of respondents saying yes, that they do a torque verification process, to about 40% no. So perfect. Thank you so much for participating in that poll. Now, where you get your calibration done is primarily up to you. You may send your tools to a local lab. You may have a service come and do them on site, or you may send them out to a lab, such as if you're purchasing tools from us, from Mountz, and you want us to do the calibration, we can certainly do that. But this is going to be a certificate that you may get back regarding the application or the tool that you have sent out. And so I just wanted to highlight a few things on here. And now typically when you get this cert, it's going to tell you which tool you're using, the serial number of that tool, the range of that tool, the unit of measurement that it's being measured in, its accuracy statement. And so for hand tools, anything under 10 Newton meters is going to be at 6%. If you go above that, then it's going to drop down to 4%. And then you're going to have the calibration date when it was done, the interval date, and then the really big item that we need to take a look at is going to be the arrival condition. Now you can see with this tool, it was found slightly below the acceptable tolerance for this tool. So these are right around 17 or so inch ounces, and our low tolerance on here is 18.8. And so this is a scenario where maybe a torque verification process may have caught this as found date earlier than before it was sent out for calibration. But this is a 6-month calibration, so maybe this tool is being used in an area that it may need more frequency. But the thing that we don't know is actually when this tool went out of calibration, and does that affect the process of the tool, of the parts that this tool was used on. And that may be a big deal, it may not be a big deal. It is basically dependent on the criticalness of the application, and again, the parts and components that was used on. But this gives us what we see here as the service performed. It was calibrated back to the manufacturer specification, and then we have our calibration readings as left, and then we have which model or sensor the unit was calibrated on, and then we have the traceability information here for that analyzer. So if we did want to go and trace this back to the wheels and weights that were used, we could do that with this. But that's typically what you'll see on a torque calibration certificate. Now, if you wanted to do this process in-house, there are some certain things that you're going to need to do that. You're going to need the appropriate equipment to do that, and that can be as simple as a torque analyzer with a torque sensor. You're going to need dedicated staff to be able to do the actual testing, and when that happens, what frequency level, and you may need a designated lab depending on what type of certification that you want to use for your actual process. Now, the equipment can be as simple as our Easy Torque 3 or any analyzer that may have a built-in sensor in it. And that's what we'll talk about and show in our demonstration portion for today's presentation. Or you could use a different type of analyzer where you would plug in a sensor to that, where you may have different types of ranges that you may want to test. And so you're giving a little bit more flexibility in using a portable device with different sensors to do that as well within your internal process. Now, let's go ahead and jump into our demo section for today. And what we'll take a look at are a couple different things with how the process might work for you, or if you are just wondering how what the process would look like. Let's move a couple things here. All right, so we have our Easy Torque 3 torque analyzer. This analyzer has a built-in torque sensor here. It has a range from 5 to 50 inch-pounds. So we'll be testing a couple tools in that particular range. Now, to tell you what is going on here on the screen, we have the ability to set a target torque that we want to test to. We can enter in what our tolerance is. In this case, it's set to 6%. And that's going to give us what our minimum value would be, our maximum value, which mode we're using, and our frequency setting. And displayed on the screen here is going to be the acceptable limit is going to be right at 12 o'clock. And then we have a green window, which is our min and our max tolerance. And then anything under that is going to be obviously under, and anything in the red is going to be over that range. Now, it doesn't quite come up on the camera, but there is a transition here from yellow to an orange color as we get closer, but it kind of shows, but I'm not sure if you can see that as well. But anyway, if we wanted to test a screwdriver, so this is one of our FG torque screwdrivers. If we want to test this tool and we want to go ahead and do that, I believe this tool is set to 7 inch-pounds. What we can do is we can come in and we can go to settings and we can enter in what our target torque is. And so we're going to be wanting 7. We can hit enter. Our tolerance is still going to be the same at plus or minus 6%. And as we are taking readings, we can have those readings automatically clear if we want. Currently it's disabled, but we could have them automatically clear anywhere from a half a second all the way up to 5 seconds before they would be cleared. You have your torque unit of measurement. So we have 7 of those. We'll stick with inch-pounds here. And then we have our mode. So there are 3 different modes. Peak, which is going to measure the highest peak torque that we see. First peak is done to calibrate click wrenches, and we'll show you what that looks like as well as we look at our wrench. Then we also have a track mode. This is primarily used for dial type of wrenches or digital tools where as we apply load to the sensor, it's going to constantly be telling us what that value is. Very much like a scale. So as you add weight or take weight, you're going to get whatever that value is on the sensor. And then we have our frequency here. For hand tools, 500 hertz is where you're going to want to be. Now, on our analyzer here, we do have a couple other things that we can use. If we go back to the operation mode, you can see that our min and max value have now changed. We're still in peak, and then we have our acceptable limits up here. We also have a graph function mode, and this will allow us to see what the actual value looks like as we apply load to the unit. So I'll use this basically when you do a calibration on a tool. You want to exercise that tool for 5 to 10 times to make sure that the tool is ready to be calibrated. So we'll do that here using our graph method or our graph function. And so as I apply load to the tool, you can see it's generating the graph. Everything within the green here is going to be acceptable limit for our tool. And so I'll just go ahead and run this a few times and we'll see what we get. Now you're not seeing any of the values change because I'm not clearing that, but I could clear it, but so nevertheless, this is what we can do to go ahead and exercise this tool. Now if we come back to our operation screen, now we could go ahead and we can take our readings to see if this tool is still performing correctly. So 7 there. All right, perfect. Now we've taken our readings and everything looks great for this particular tool. Now, if we did need to make adjustments to that, if that was going to be part of our process, to say if this tool was out of the calibration and we needed to make adjustments to that, we can do that with this particular tool, but this is a preset tool, obviously, because there's no scale on the outside of it. So it is set internally. We can go ahead and we can remove the end cap here. And then we have another smaller set screw inside here that I'll loosen up. And then we can take our key and we can make adjustments to the internal mechanism inside here. And so if I go ahead and I turn the tool down, so say for example we were too high, I can go ahead and turn the setting mechanism inside counterclockwise, and that will go ahead and reduce the amount of torque output that the tool is producing. And we can go ahead and do that. You can see that those last readings that we've taken were outside of the range. obviously. But if we wanted to get a more clear view of what is actually happening with our min max values. Now this includes the three that we just added that were outside the range because I turned it down. But if we wanted to do a CM or CMK study to where we want to test the output of the tool, and so if any of you are in that world of the statistics, we can do that. We can reset all of our values, and you can do your CM and CMK study. Typically, when we're doing that, you're looking at running the tool for 40 to 50 times without stopping and moving that, and then you'll be able to gather your CM and CMK. So if you're doing any type of tool reliability study, or you're doing some process control studies where you're trying to improve, you can do that by using the CMK to make sure that you're ruling out your tool in your process, but that's a whole nother discussion. But anyway, that is using our advanced view, where you can get your average, your min, your max, your standard deviation, and your CM and CMK results in the advanced view. Now, if we want to go ahead and use this sensor with a torque wrench, we can do that as well. So I've got a click style torque wrench here, one of our EPT tools, and this is a click wrench, and so when this wrench reaches torque, it simply clicks and does that. We also have a cam over style wrench that acts more like a screwdriver that simply slips, and that would operate just like we would with the screwdriver. But let's go ahead and change this mode to first peak. And then we can go ahead and go back to our operation screen. And I think we're somewhere in a ballpark around 18 inch-pounds or so. Yep. And so what's unique about the first peak mode is that it allows us to capture the value at which the wrench actually will go ahead and reach before or when the click happens. Now, because of the makeup of a click wrench, it's a very operator dependent type of tool. And so if the operator keeps pulling on it after the click, we are adding additional torque to that. And so if we were using it in a peak mode, we may see very erratic readings as it relates to that. So let's go ahead and we'll reset our values. Now, if I pull the wrench correctly and get the click, that was not correct. There we go. So I have it set to 18.5 inch-pounds, and we're getting around 17.5 or so. Now, what you'll see here is that we have two different values on the screen. So the larger value is going to be where the wrench clicks, and then the second number is going to be where the wrench actually stops. And so in this case, we'll move that to 17.5. We can clear these. And if I pull correctly, we can get the same values between the two. However, if I pull a little quicker, you can see that the wrench itself can be deceiving as far as what the end result is. So our wrench is clicking at 17 or so inch-pounds, but our final result is much higher than that. So it just depends, again, on how the wrench is being used. You may see operators on the line that may sometimes do a double click, and if they do, sometimes they're adding much more torque to the actual operation. But if you are calibrating or using click wrenches, the same type of philosophy is required, where you'll warm up the tool, then you'll go ahead and you'll take your readings. And so depending on if you pull the wrench correctly, you can eliminate the over torque that you may see during that first peak type of scenario. But again, oftentimes, if you just pull it with just a little more force, you're going to see a tremendous amount of over torque that can happen. So if you are experiencing that with the use of a click wrench, you may want to consider switching that particular application to a cam over style wrench. And so with that, that'll kind of wrap up today's presentation. And so we'll move on to our questions and answer section. So let's go ahead and find out if we have any questions. Chris, do we have any questions?
Morning, Dave. Yeah, we had a couple questions here. What is the recommended number of test data readings when you're calibrating a screwdriver or wrench?
So, like I mentioned, you want to do test the tool or warm it up for 5 to 10 cycles, and then most calibrations are going to be take 5 readings after that point. But again, if you're going to be doing this in-house, you can basically set that value at whatever you like, but the industry standard is 5 readings.
All right, thanks. The other one we had was, can you explain or show how the save and export the test data they were showing on the tester?
Oh, yes. So let's pop back here. So on the analyzer here, we do have the ability to do a couple different things. If we wanted to add a tool serial number to any readings, we can do that. And then any readings that we take after that will have that associated with the data that we have the ability to collect. So we do have a USB port on the side of the unit here that you can export data out or readings. And then we also have an SD card that is located in the controller, and that we can then go ahead and save all of that data on the card, and that information then can be downloaded at a later time. The file structure for these go by the year, the month, and then the day, and those will give you all of those readings. And then if you are adding a serial number to that, that'll be one of the data fields in the string of text, along with the target, the min, max, all of these reading, plus whatever the value was that you achieved.
All right, Dave, thanks. Looks like that's all we had.
All right, great. Thank you so much for joining us today, and we hope you have a good rest of your Thursday, and we look forward to seeing you next month in our next webinar. Thanks so much, and have a good day.
Recording stopped.